There's an odd sense in which my involvement in the climate issue started more than 50 years ago, before there was a climate issue. Because as some of you may remember, the older people here, this is really the second round. 50 years ago, population played exactly the same role in the public dialogue that climate does now. Increasing world population was the looming catastrophe that was going to make terrible things happen unless we did something drastic to stop it. And I got involved in that discussion, wrote a piece for the Population Council in which I tried to work out the positive and negative effects of having more people, and concluded that the size of the effect was sufficiently uncertain that I could not tell whether the net was a gain or a loss. As it happens, as again some of you may remember, it turned out that whether or not I was correct, the orthodoxy at the time was wrong, because that orthodoxy made a specific prediction. Its prediction was that if nothing drastic was done about population growth, poor countries were going to get poorer and hungrier. The population of poor countries continued to grow, and poor countries got richer and less hungry. So in that sense, it really was, it turned out, a wet firecracker. This does not prevent people from taking essentially the same position when you get a second round of that with climate. There are two ways of looking at the question of what are the effects of climate change. I should say I am not going to be talking about the climatological arguments about how much climate change we can expect. I am not an expert in that, I'm an economist. What I am trying to look at is, assuming the IPCC is correct in its projections, what are the net effects on humans of the climate change that they predict, or project if you prefer. And there are basically two ways of answering that question. One of them is an a priori argument. You can say, do we have reasons to expect that warming of that degree, along with some other effects, will make us worse off? And the alternative way is to try to actually estimate the various effects that will be produced, and as best you can, cost them. Say, how much will this make us worse off? How much will this make us better off? And try to see if the sum is positive or negative. The a priori argument is very weak. The current climate of the Earth was not designed for us, nor were we designed for it. Over the period at which our species evolved, the climate of Earth has changed quite a lot. We've had repeated glaciations. Furthermore, the climate at present, the areas over which the human race prospers, have a range of climates much larger than the projected range for the next century or two due to climate change. So we know that people can live, we can be pretty sure people can live in Minnesota even if it gets as warm as Iowa, which is roughly what we're talking about. That's the scale of the changes. So there is only one a priori argument that I can see for climate change being bad, and that would be equally true for warming or cooling. And that is that in each place where humans live, they have presently optimized their behavior to the existing climate. So if you're someplace cold, you have well-insulated houses. Someplace hot, you have air conditioning. If you're a farmer, you grow those crop varieties that best thrive in the particular environment you're in. So that means that any change at all will tend to have some negative effects aside from any effects due to the nature of the change. That people will have to, as it were, from an economist standpoint, scrap some of their sunk costs and reproduce them. Right? That, however, for humans is a very small effect. Climate change, warming so far, has been roughly 1 degree a century. The IPCC thinks that it may get as high as 2 degrees a century if we don't do much about it. That is a very slow rate of change. People will tell you why I remember it was cooler when I was young. They are mistaken. Their memory is fooling them because at least nobody I know has a good enough memory to be able to recognize a ½ degree change in the average temperature of his environment. All right? So people believe it, but it is not in fact true. So from the standpoint of humans, by the time that the temperature or other features of the climate have changed enough so a farmer would want to change the variety he's growing, he will already have changed the variety he's growing because plant breeders bring out new varieties, market demands change. We're in a changing world, and in a changing world, one more change doesn't matter very much. On the other hand, it might be a problem for some species other than humans, some of which we depend on. That a species that can evolve quickly can adapt to climate change. A species that can move its range quickly can adapt where it is to climate change, move a little bit farther north if it gets too warm for it. Trees evolve slowly because they have long generations, and they move slowly. They do move, that is to say, trees grow up at one edge of the forest and die at the other edge, but that's a fairly small effect, and there may be other species for which that's true. So I think you have to list as a negative effect of unknown but probably not enormous size the adjustment costs for species that can't adjust very quickly. All right? Next, let's try to look at the actual projected, insofar as we can, costs and benefits. And again, I'm using the IPCC projections. One definite cost is sea level rise. Again, this gets greatly exaggerated. Roughly speaking, the high end of the IPCC estimate for the end of the century is about 1 meter. That's, roughly speaking, half the difference between high tide and low tide. The figure I came across for the east coast of the US in a book that was discussing something relevant is that a foot of sea level rise on average moves the coastline by about 100 feet. So at least judging by that, it's obviously going to be more in some places and less than others, but as a rough picture of what's happening, the coastline might have moved in by as much of 100 meters by the end of the century due to sea level rise. And that's be inconvenient for a few people who are living on the coast, but that's a very, very small cost in terms of the humanity as well. Second, there is the cost of more heat waves. That extreme heat kills people, and the warmer things are, the more cases of extreme heat there will be. So that's a predicted negative effect. There are also possible costs. One of the ones, probably the one that I find hardest to estimate, is what is misleadingly called acidification. That is to say, lowering the pH of the ocean. Carbon dioxide dissolved in water is carbonic acid. So the more carbon dioxide there is, the lower the pH of the ocean. The closer to acid, the farther from base. Calling it acidification is technically crude but misleading because it makes it sound as though the ocean is becoming acid. But in fact, the ocean is presently basic. So lowering its pH moves it towards neutral. What's actually happening is the very gradual neutralization of the ocean, and it would have to go enormously farther than projected before it becomes acid at all. But even given that, it might be a serious cost because, again, existing organisms are adapted to their current environment, and we simply don't know how sensitive fish or the microorganisms that fish ultimately live on are to changing pH. So that's one of the ones where I think you have to say it could turn out to be quite large, it could turn out to be no cost at all. We don't have a good way of knowing. Another uncertain one is the effect of climate change on agriculture. The prediction is that there will on net be more rain due to the fact that at a warmer temperature the air holds more water vapor. But it is argued at least that it may be less even. So you could, on the one hand, have more water available for agriculture, but also more uneven water and therefore the potential of flooding. And if you have a good system for storing water behind dams and releasing it when you need to, that's a pretty clear benefit. If you don't, it might be a loss. Another possible result in the other direction, however, is greening the Sahara and the Sahel. If you actually, most reporters, if they look at the IPCC, only read the summary for policymakers, which is a highly biased and selected piece. If you read the whole thing, one of the things you discover is that the IPCC people think that one possible result of climate change is greening the Sahara and the Sahel, which would be a very large benefit, which never gets mentioned when people are giving newspaper summaries of what's in there. Another effect, which is ambiguous, is the effect on tropical cyclones. My standard example of why you shouldn't rely on the summary for policymakers is that it tells you correctly that the average strength of cyclones is going to increase. What it doesn't tell, no. Do I have it right? Just to remember how they put it. Right. What they don't tell you is the reason the average strength is increased is that the number of low-end cyclones is going down. And that you can get again reading the body. Now, to be fair, there is a second reason, because the body of the report does project that the existing high-end ones will become somewhat stronger. But it does not, the way the summary for policymaker puts it is the percentage of high-end and which is category 4 and 5 cyclones, hurricanes. They're all tropical cyclones is the general term, and it's called a hurricane in one ocean and a typhoon in a different ocean. But the percentage of high-end ones increases, and they don't tell you that the reason the percentage of high-end ones is increasing is that there are going to be fewer low-end ones, that the number of high-end ones is expected to stay about the same. That, again, is in the body of the report. On the other hand, the body of the report does say that the existing high-end ones are going to get somewhat stronger. So there is a negative effect in the high-end ones getting stronger, a positive effect in lower category 1 through 3, hurricane, typhoons, etc., making it ambiguous. How about benefits? There is a very large benefit which almost nobody talks about, which happens to be the single most predictable effect of climate change. And that is carbon dioxide fertilization. Carbon dioxide is an input to photosynthesis. It has been known for a very long time that if you increase the amount of carbon dioxide in the air a plant is growing in, you increase its yield. And this has been tested experimentally. People with greenhouses sometimes pump CO2 into the greenhouses in order to raise their yield. The reason this is the most certain effect is that it only depends on the first step in the causation. All right, you have a complicated system, namely climate. The first step is increasing CO2. That by itself, whatever the other effects is, will increase yield of plants, of crop plants. I should say, it's a little complicated. There turn out to be two different mechanisms for photosynthesis called C3 and C4. Most crop plants are C3. However, maize and a few others, including, I think, sugarcane, are C4. For C3, roughly speaking, doubling the CO2 concentration, which is about what the IPCC expects by the end of the century, increases yield by about 20%. So that's a very large increase in the total amount of wheat, rice, and other things that we have. For C4 crops, just increasing it has little effect on yield if there's enough water. But increasing CO2 reduces water requirements for all plants. And the reason it does that is that plants lose water passing air through their leaves. Why do they have to pass air through the leaves? In order to get carbon, in order to build their fruits and branches and so forth. The more carbon dioxide there is in the air, the less air that has to pass through their leaves. Hence, if C4 plants are water stressed, if they are facing a limited supply of water, their yield goes up as well. So this is, as I say, the single thing we can be surest of. That doesn't tell us that we can be sure yield will go up, because there could be other effects making it go down. But we know that there will be CO2 fertilization, and its effect will be a quite substantial increase in yield. Furthermore, one of the other things you can find in the IPCC report, which for some odd reason doesn't make it into the summary for policymakers, is the opinion that the Earth is on net greening. That is, that the total amount of the Earth that's got leaves on it is going up, and that the reason it is greening is CO2 fertilization, because the CO2 concentration has already increased substantially. So that, again, most people would say greening the Earth is a good thing, and yet almost nobody who's talking about the terrible effects of climate change mentions that one, which is one of the good effects. Next effect is that at the same time that more extreme heat results in more people dying, less extreme cold results in fewer people dying. The question of the effect of temperature on people dying is a very complicated question. And there is a whole literature, largely in The Lancet, which is a British medical magazine, in which people try to do very elaborate statistical estimates using data that involves day-by-day data for a city on what the temperature was on that day and how many people died. And there are, I guess, 3 interesting results from that research. I should say, I don't think you can trust it very much, not because they're dishonest, but because it's a very hard problem to tease out what causes what. But first estimate is that deaths from both cold and heat are not mainly from extreme temperatures. That mainly what's going on is you can find the temperature in a city at which deaths on days at that temperature are lowest. Actually, on days at that temperature in the next 20 days, because they assume it might take a little while for you to die. You can then say how much higher is the death rate if the temperature is a degree lower, a degree higher, 2 degrees lower, 2 degrees higher, and so forth. And that's where they get most of their effects. And it turns out that the extra death rate from extreme heat and extreme cold is a small part of it, due to the fact that although extreme heat and extreme cold are much more deadly than mild heat and mild cold, they're also much less common. However, the conclusion from that work is that the number of people who die because it's too cold is much greater than the number who die because it's too hot. Depending on whose research you're looking at, the figure will vary, but it's something like 10 or 15 times as high. Now, I should say, to be fair, that Gasparini, who's one of the people who's worked in this area, who I've read 2 articles by, thinks that the effect over the rest of the century will nonetheless be an increased death from temperature change, because he thinks, if I understand him correctly, that although the average number of people who die from cold is much higher than from heat, the increase in one number is much larger than the decrease in the other. That if you think about a more steeply sloped graph. He may or may not be right. If you're sufficiently curious, you can go to my Substack, you can go to my webpage. My webpage near the top has a link to my Substack posts, and they are sorted by topic. And a bunch of them are on climate, and that includes, I think, 2 on the climate temperature, on the temperature mortality question, which is a complicated question that I've tried to look at, in particular, tried to compensate for some of the simplifying assumptions that Gasparini makes in his calculation. But I should add that there is a calculation using this approach of the effect of warming so far. And that calculation shows that it has decreased mortality, that fewer people have died, not more, and it's done by the same people. Gasparini is a co-author, no, not a lead author of that one, but it's a bunch of climate statisticians, I guess, mainly, who are doing that. Second thing one ought to realize, which is relevant to this, is that the pattern of greenhouse gas warming is biased in our favor. What do I mean by that? I mean that the amount of warming is larger in cold places and cold seasons than in hot places and hot seasons. And the reason for that is very straightforward physics. Water vapor is also a greenhouse gas. The more of one greenhouse gas is in the air, the less the effect of adding another. You can't block more than 100% of the infrared coming up from the Earth, which is what's basically happening. The warmer the environment is, the more water vapor is in the air. That's the same reason that we expect more rain. So that means, and this is a pattern you can easily see if you actually read the IPCC report and look at their graphs of projected effects, that you get more warming at the poles than in the equator, and you get more warming in the winter than in the summer. And you can see those on their tables and their maps and so forth. So since warming is generally a good thing when it's cold and a bad thing when it's hot, that means that the pattern of warming is biased in our favor. I mentioned the loss of a little land from sea level rise, but there is another and much larger effect in the other direction. Because if you look, it's interesting to look at a temperature map of the Earth showing average temperature or temperature in January or whatever temperature you want to look at, and a population density map in the Earth. And you discover from that that high temperatures do not keep people from living or growing crops. That in fact, some of the hottest average temperature parts of the world are densely populated. The Philippines is the one that I happen to have noticed, but it's true of a fair number of others. On the other hand, cold does prevent people. So if you ask, where does population density drop to zero? Mostly, it's as you get to the north and towards the north and south poles. All right? What happens as average temperatures go up? Especially as they go up more in the cold areas. Temperature contours move towards the poles. That the point that used to be where January temperatures got down to zero, now they go down to zero 100 miles farther north because the overall is warming. So I did a calculation. I did what we refer to as a Fermi calculation, meaning a very rough back-of-the-envelope calculation. There's lots of more stuff I could look at. But I found a temperature contour map. I should say, you aren't going to gain any significant amount of land in the south, at the South Pole, because it's not going to get warm enough to melt Antarctica. The relevant areas are basically Alaska, Canada, Siberia, Scandinavia, more or less, the northern extreme temperatures. So what I did was to simply calculate with a 3-degree rise in average temperature, how large the rise will be in polar temperatures, which you can get a reasonable idea from the IPCC tables, and then look at a contour map to see how close together the contours are, showing 5 degrees, 0 degrees, minus 5 degrees, and so forth, and then just see how much land is in the area that the contour is moving up. Turns out that the increase in the amount of land that's just warm enough for people to live in is roughly equal to the area of the United States. It is not a trivial effect. It is between 2 and 3 orders of magnitude larger than the land lost by sea level. Now, you might point out that's not going to be very good land because, after all, it's just barely warm enough. But at the same time, the next chunk of land south of it used to be just barely warm enough, is now, pretty good, and so forth down. So if you think about it from that standpoint, if anything, since the Earth gets bigger around as you go along it, my estimate of the area of the U.S. is probably an underestimate of the increase in the amount of useful land due to this. Now, I say useful land, I only mean useful in terms of temperature. Obviously, some of this land will be barren, dry, and one reason or another not usable. But that's true of the rest of the Earth as well. But it's even true of parts of the United States, as you may know, I guess. If you live in New Hampshire, you may not notice these things. But if you fly here from California, you notice there are some yellow places underneath you. So in any way, the basic point here is that the effect of increased usable land is a very large one. It is not clear there is any effect of lost usable land. We don't have any places that have an average temperature 2 degrees higher than the Philippines now, so we don't know if anybody would live in them. All we know is that the hottest it gets in practice, Death Valley doesn't count, it's a very small area, that the hottest it gets is places where people live some places where people live densely and grow crops. So I think there is no good reason to think that you would lose very much land from getting too hot, although you certainly might lose some. A lot of this you can't be very careful of. If you want to see my calculations, again, one of my Substack posts runs through that Fermi estimate, my attempt to estimate the effect. If you look, what is my conclusion? My basic conclusion is that we do not have any good reason to expect that climate change will make us worse off. It might, but that the benefits from climate change could easily be larger than the costs. Both of them are quite uncertain. Why is there a public impression that, of course, everyone knows that climate change is a bad thing? And a lot of it is a biased presentation by people who either believe it themselves or have some reason to want you to believe it. And I mentioned the summary for policymakers, which is a very short document that goes along with the IPCC report, which is a very long document. I mentioned the fact that they correctly report that climate change will increase the proportion of high-end tropical cyclones, but don't mention that the reason is because the number of low-end ones is going down. If you look in the summary for policymakers, you observe that they have a map of the Earth showing in what regions drought is increasing or decreasing. And they show it decreasing in maybe 2 regions and increasing in maybe 30. They don't ever mention the fact that, according to the report, Earth is on net greening. What I think is going on there, although I don't know, is that their definition of drought is measured by the amount of water in the soil. However, the higher the CO2 concentration, the less water you need in the soil for plants to grow. So my guess is that they are correctly reporting the evidence they have, but incorrectly reporting the implication of that evidence. Let me give you another example. This is one that I spent quite a lot of time on. I had an exchange with an economist who said that, of course, I was wrong in thinking that we didn't know what the net effect was. And I said, well, how do you find out? And he said, well, look at this article by Renard et al., which has come out in Nature recently, and they calculated the net cost of an additional ton of carbon in the atmosphere. So I read the article. The article gets about half of its cost from increased mortality due to warming. Their calculation for doing that uses mortality data from the recent past. They are summing costs for the next 3 centuries. All right? One of the things that affects the chance of your dying from hot or cold temperature is how good medicine is. They are implicitly assuming that there will be no medical improvement for the next 300 years. Well, 80 years, 276 years now. All right? Another thing that affects how vulnerable you are to temperature is how rich you are. That poor people have to go out in bad weather and rich people don't. Rich people have air conditioning and poor people don't. On the model that they are using, per capita income, well, at least GNP per capita, which is what they're giving, triples by the end of the century and goes up more than tenfold by the end of the period they're covering. They make no allowance for any effect of that on mortality from temperature. So even aside from the general uncertainty of anybody's estimates of temperature mortality, they are ignoring 2 very large effects, which they know they can expect on their own models, both of which would greatly reduce their figure. At the end of the article, of the Renard article, they spend, I think, 2 paragraphs discussing reasons why their estimate might be too low. I should say their estimate is a bit more than 3 times what was the previous estimate being used by the EPA. And their article is being looked at by the EPA. They said so. That is, the EPA said so. They spend no words at all on reasons why their estimate might be too high, although we know that there are some very obvious reasons. Now, there are also some problems with the agricultural, which is the other half. I should say, to their credit, they don't think that sea level rise is going to matter very much. It's like, 2% or something of their total cost. So their main things are increased mortality due to warming and reduced agricultural output due to effects other than CO2 fertilization. And as far as I can tell, their estimate for the effect of fertilization, which they cite to a source, is in fact sizably lower than the current consensus figure. But anyway, that would be more complicated. But you can look for yourself at, again, my Substack post, which is one of them is a very detailed critique of Dessler's article. And I should, it's not Dessler, sorry, of the Rennert article, Rennert et al. And I should say I sent a copy of my critique to the corresponding corresponding author. He tells me that he sent it to everybody else, and I got no response at all. I don't know if they didn't read it, if they have rebuttals that seem obvious to them and not to me, or if they don't care whether what they say is true, as long as it's the right answer for their political purposes and professional purposes. I would predict that their careers would have done considerably worse if they had concluded that the cost was a third of the old cost rather than 3 times the old cost. Let me give you another example, and that's an elementary textbook in climate science called Introduction to Modern Climate Change by Andrew Dessler. I've corresponded with the author. He has a chapter on consequences of climate change. That chapter does not mention a single positive consequence of climate change. He does mention elsewhere in the book that there will be less extreme cold, but he then asserts that more Americans die from heat than from cold. And he does not give any source for that claim. I have a guess about where he got it, but in fact, there is a published article by people from the Center for Disease Control who counted death certificates, and they concluded that in America about twice as many people die of cold than of heat. But you don't really have to do that, because if that is a graph of number of deaths by month. Looking at that graph, would you guess that heat or cold is more dangerous? All right? Not an absolute proof. Maybe people are dying because they slip on the snow or something. But that certainly ought to make you say, my best guess is. And that's data that you can get very easily, right? Get it off the web. I should say I have pointed these things out to Dessler. And some other things I'll talk about in a minute, and we will see. His book is in its 3rd edition at the moment, and when there's a 4th edition, we will see whether he corrects them. My guess is he won't, but I could be wrong. He could be an honest man who just never checks facts that he likes to believe, which is a natural, if unfortunate, pattern. Next, another thing in Dessler, which I thought was rather interesting, is that he asserts that at the sea level, that if you take sea level rise estimates and you take the middle of the range of projections and apply that to Florida, this is for the end of the century, the 2100, that the result is to flood 9% of Florida land occupied by 10% of the population of Florida. And he cites his source. His source, however, is not a peer-reviewed journal article. His source is a report commissioned by the Environmental Defense Fund, which is, of course, an environmentalist group. But that source cites its source. And its source is indeed a published journal article by Titus and Richmond. But you then read these three sources. The sea level rise that Dessler is asserting, the middle of his range, is 60 centimeters. The sea level rise that's being used in the source he got his conclusion about flooding from is 68.6 centimeters. The sea level rise in the source that they used is 80 centimeters. So he is in fact making a conclusion that he believes that he has support for, but the conclusion is for sea level rise about a third higher than what he says is the sea level rise that will produce that. But it's worse than that, because he says that this 9% of the land will contain 10% of the population. And that seems a little unlikely, because you would think that low swampy land is not likely to be well populated. But you can in fact do a little more than that. That is a map of population density in Florida. This is the Everglades. That is most of the area that's being flooded. You will note that nobody lives there, right? That's a population density. Part of it is less than 5 people per square mile, and part of it gets as high as about 10 to 20. There is one who, I should say, I went to his source's source, because he doesn't give such a map. But his source's source shows where they expect to be flooded. And those black lines are surrounding the areas they think will be flooded, and you will notice that with one small exception, none of them are in densely populated areas. It is therefore absolutely impossible that the claim that the percentage of the population that is flooded is larger than the percentage of the land, and yet that's the claim that he makes. And I've pointed this out to him too, and we will see whether or not he responds to, whether or not he changes it. So, general points. The effects of climate change, as this should make clear, are very complicated. With a complicated thing like that, getting an answer involves a lot of judgment calls. How likely do you think it is that important microorganisms in the ocean will die if the pH goes down a little bit? How likely do you think it is that the estimates on increased force of tropical cyclones will turn out to be on the low end rather than on the high end, and so forth and so on? If you know what the answer is, if you know what answer you expect to get, well, naturally you make all the judgment calls in the direction that fits that answer, and you get the answer you want. So therefore, it is perfectly straightforward for an honest but biased person to go through what I'm doing and reach the conclusion, yeah, it's pretty clear that we're going to be in trouble if sea level rises, if climate warms. On the other hand, it is not possible, as far as I can tell, for an intelligent and honest person to reach a conclusion corresponding to the public discussion, because the public discussion vastly exaggerates the scientific discussion. William Nordhaus got a Nobel Prize for trying to do estimates of the economic effect of climate change. I think, as I read it, that he is in fact biased in the same direction as everybody else, but he's also honest in trying to do numbers. And if you read what he says, yes, it's a terrible problem. If you look at his numbers, you discover, well, he had an article, there was a Wall Street Journal op-ed some years ago by a number of people who were arguing that global warming is not an imminent catastrophe that requires immediate action. And he wrote a rebuttal to that. And in the rebuttal, he gave his estimate of how much worse off we would be if we waited for 50 years to do anything about global warming, compared to doing exactly the right things tomorrow. And he concluded that the result is that we would be worse off by $4.1 trillion. And he added, wars have been fought over less than that. But of course, this is $4.1 trillion spread over most of a century, maybe longer. He's a little unclear about how long he's summering over, and over the entire globe. And that turns out to be about 0.05% of world GNP for the rest of the century. So if you look at his verbiage, he is indeed saying that global warming is a terrible thing. If you look at his numbers, he is saying it doesn't really matter if we wait 50 years. He is not, he is not, as far as I can tell, recognizing the argument for waiting which is that the longer you wait, the more information you have. So if you have a gamble and you say, well, I think it's worth making this gamble, but making it might lose me money, if you can wait 10 or 20 years and get better information, then you can avoid making the gamble. You can avoid spending a lot holding down climate change if climate change turns out to be good for us, and still do almost as well holding it down if it turns out to be bad for us. And as far as I can tell, he never considers that which an economist ought to be considering, because that's option value kind of issue. He also says in his book on climate change, the best guess in this book is the economic damages from climate change with no interventions will be on the order of 2.5% of world output per year by the end of the 21st century. Now, most of the projections people are making assume that world income continues to grow, world income per capita continues to grow, so they expect that, roughly speaking, the per capita income at the end of the century will be about 3 times what it is now. And what he is saying is, due to climate change, if you do nothing, it won't be 300% of what it now is. It'll only be about 291% of what it now is. So, in general, the public, the sort of catastrophist discussion really is not supported by respectable scientific work, even the respectable scientific work of the people I disagree with, such as Nordhaus. Let me show you one more thing, because people talk as if what we're coming in for is an unparalleled Earth climate. That is a graph of the average temperature of the Earth going back 500 million years. All right, people say correctly that this is probably the hottest it's been in the last few thousand years. The Earth is a great deal more than a few thousand years old. And this is where we are, and indeed it's going steeply up. All of that blue stuff is ice age. An ice age to a geologist is the time when there is a ice cap on one or both. Right? What non-geologists call ice ages, geologists call glaciations. And a single ice age has repeated glaciations and interglacial periods. And we're currently in an interglacial period. So as you can see, it is warm compared to the recent past, rather cold compared to even the last 100 million years, let alone the past. So it is not as if continued warming is going to put the Earth in a situation it has not had many times before. For much more on this stuff, see that's my post. That's the link to the sorted posts. That's my webpage, which has lots of stuff on it. Second one is the sorted posts from my Substack. That's the Substack in general. That's my old my old blog, which has some more stuff, but I've basically pretty much abandoned that in favor of a Substack. And I put out a Substack post every 3 days, and only a small percentage of them are on climate, but by now that's still quite a lot of, maybe 30 posts by now, covering a wide range of different things. I should mention that the Substack post I was just working on maybe 2 hours ago, is a follow-up to the debate that I had with Gene Epstein. Because I have emailed Gene suggesting another debate next year. And I was, as those of you who attended should realize, I wasn't very happy with the proposition we ended up debating. It's not Gene's fault. We had both agreed on it, but we couldn't find a better one. And so I have proposed what I think is a much more interesting topic. And the topic I have proposed to him is, does Chicago school or Austrian school provide better economic arguments for libertarianism? And that seems to me a very interesting question. There are a lot of libertarians who apparently believe that Austrian is the libertarian economics. I think they're mistaken. I am prepared to argue, on the contrary, that Chicago School economics is not only on the whole somewhat better, it also provides stronger arguments for libertarianism. And one of the problems with the previous debate was that given the way it was set up, I didn't know what arguments I would have to make until I heard his speech, because it didn't say what intuitions he was going to claim. He didn't know what arguments he'd have to rebut until he heard my speech, because he didn't know which of the things he claimed I would say were wrong, and which I would say Chicago has those too, which require very different responses. So I'm going to solve that problem. I am working on a Substack post that is my argument for next year's debate. And Gene is welcome to read it. I believe I have good arguments, and I am perfectly willing to defend them even after he's seen them. I don't think I require a surprise attack, as it were. I hope he will do the same thing somewhere, but I don't require him to. That's up to him. So anyway, that's going to be not my next Substack post is going to be something else, because I'm not going to have that finished by tomorrow, which is when the next one goes, but I've got about 8 in the can for times when I'm not free to write. All right, thank you.